Now it's time to bring in some detail. We prepared the corridor walls according to their assigned design. The result of that goes into one big subnetwork that is used to place the single designs. That subnetwork also needs the original corridor walls for reference. So let's connect that into the second input. In here I will once again have networks that handle the individual design. Believe me, we will need that to keep everything organized. So bring in both incoming nulls into the inputs of the newly created pipe subnetwork. Subnetwork, we start again by limiting the geometry to the one design we want to deal with, the design with ID 1. We can then copy that over to the second input, and even though this is the complete structure with all the walls and gateways, it's enough to blast that down to design 1. So here we have the walls without the end panel tweaking. But now to the creation of the pipe design. But these are just ideas what we could place in those corridors. The level of variance and detail is limitless. For this course I have to keep it somewhat simple, but at the same time I want to give you all the tools you need to create cool designs. So let's get to it. I start with the end panel of the pipe design, and instead of using a for each subnetwork, this time I'm going for the newer for each sub. We don't need the piece attribute, and then create the first attribute wrangle in that loop. With this one, we want to find the points that are not the corner of the whole wall. If I display the normals, you can see that we could use the normal vector to find it would be the same approach as with the corners of the gateways. But this time I want to make use of the color. And since it's a color, I address it with @cd.r for the first element of the vector. I could also write x, but color, it makes more sense this way. So if r is not equals 1, it means we have a corner point where we mixed the color. That point needs to be removed. But I still need the corner point as reference in another stream. So copy and reverse that condition. If the red channel is 1, then remove it. For this operation I only need the points at the top. So let's squeeze another attribute wrangle in between the start of the for each loop and the finding of the corner point. And here we delete the point that has 0 on the y-axis. That leaves me with these 2 points, one with a straight and the one at the corner. I want to do something more with the point with the straight normal. This is supposed to be the point where I later on bring in the closing element of the pipes. So the problem to solve at this stage direction from where pipes are coming in and then connect them to the wall. And this has to work on both sides of the corridor. The point for the pipe placement also needs to be slightly pushed into the corridor. So let's add the normal multiplier 1 onto the point position. Now we have to tilt the normal either to the left or the right side, depending on the direction of the corridor. To do that we need to test the normal. And we can make that test in a similar way as we did with we still have the other corner point for that test. So let's connect that to the second input. First we create the cross product of the current normal and the y-axis. This way the normal is either pointing into the corridor or towards. Then I create a new position that takes our main point and adds that normal onto it. For that position I create a point cloud with a radius of about 0.4 and search for only one point. If the point cloud finds that point, the facing towards the corner, not what I want. I want this point in the direction of the corridor. So in that case I multiply the normal with -1 and also create an attribute called switch that I can later use to establish. Let's template the incoming structure just to see if this normal is really pointing in the right direction, and it does. Now this point is still at the top of the original primitive. The pivot point should be a bit lower, so subtract from the position 5 units. So here we're going to place the pipe segment. Below that I also want to include some geometry. Now that geometry should also take the color of this particular corridor. So first we need to set up that logic. This color setting, later on used in all of the designs. To start off, let's bring in all the control parameters we established in the control node. We have the one color toggle, the one main color toggle, and for that case, the main color vector. As usual, bring in the parameters and copy the relative reference. For the color vector, you need to channel individually. The parameter name will be the same, but in addition with an R, G, and B. Logic is pretty straightforward. First we check which toggle is true. We can either have one color, and if that's not active, we check if one main color is active. If none of those are true, we go with a random color on the corridor. Now for the color distribution itself, first I need to get the shared corridor ID if the one color is selected. Then I need additional float variables to save random values that I'm going to create. Each vector get the result of a rand function that includes the ID, a channel seed, and an additional value, so each channel is independent. Copy that for the other channels and change the additional value. And then we set those elements for the color vector. That means we also need to define that vector. We have a typo somewhere. I was too quick with that bracket. Now if one color is not active, we need to get the color vector. So this block is simple enough. For all other cases, we need the same block as before. But this time, the ID has to come from the corridor ID and not from the shared one. If color was selected, we need to set that vector as new point attribute. Now that the color setting is done, we can continue with this panel. My plan is to create something that will be below the pipes. And since this is the whatever I create, this has to be the closing part for that. So let's start by bringing this down. Create an attribute wrangle that only selects the points that are above 0 on the y-axis, or the points that are selected by this wrangle down by 1.7 units. Next we're going to use a poly extrude to create a shape on the inside of the corridor. Let's template the incoming walls to see if this is the correct side. Then I want to lower the top only from the front primitive. So I grab all the points from the first primitive with the function primPoints. As index I use 0 since that is the ID of that primitive. You can check that by displaying the primitive numbers. We need a position vector as usual and then loop over all of those points. We get that position and check if the position in y is higher than 0. We lower it and set the new position for that point. And just as a reminder, of course there are easier ways to get this kind of a shape. But this is a Vex course, so we're still trying to do as much as possible with Vex. At least for the most. Since we used Vex to create an attribute called switch earlier when we tested the normal, we can now create a switch and use that attribute to control which path the logic will take. We get that attribute with the point function while the object path to the test normal wrangle. So the switch has to decide which one of these blast nodes are relevant right now. As you can see by the dotted line, in the current scenario, the right blast node is active. When we switch over to the test normal wrangle and look at the point and its normal, we can conclude that the corridor is coming from the right side, while the whole structure has to end on the left. The primitive numbers on this geometry the same, no matter on which side it is. So in this case, I want to blast primitive 3 and 2. On the other side, it's the primitive 1 and 2. Bottom primitive, while the other one is the side pointing towards the corridor. Whatever side comes out of the switch node will then go into a poly bevel. And since I did that without the side facing the corridor, it will be a perfect match for we create for the middle parts. We only need to make sure that the connecting part uses the exact same settings as this poly bevel. We should also make sure that the normals are in place, and we can also pack this geometry. So this was the ending section for the lower part, but we still have to create the ending pipe section. As soon as it will be combined in this merge.